here with Sam from the Hub, and one of the things that they do here is, with a funky little piece of kit like this, is 3D scanning. Now, it sounds like it does what it says on the tin, but exactly what is 3D scanning and why would it be useful for someone like me or someone out trying to go as fast as they can on a bike?
Sure, well the greatest thing about this new 3D scanning technology is we can scan athletes whilst they're on their position on their bike. I just run around them in a couple of minutes, capture their 3D geometry accurate to 1/10 of a millimetre, and we can use this data to produce life-size 3D mannequins of that athlete. We could then potentially lead that into CFD testing to run alongside wind tunnels and suit manufacturing.
So in essence, you can use an athlete in the tunnel, but rather than have them spend time in the tunnel, you've basically got a replica of them doing all the testing while they're out doing their training.
So that development in the wind tunnel continue whilst they're around the world competing, and these mannequins won't move like the athlete, so you could test more intricate things where the measurements are less noisy.
So Sam, most of us will have heard the term marginal gains, and so with a mannequin, I guess you can use that to find really small, minute gains in different areas rather than use an athlete.
Yes, that's correct. Because the mannequin doesn't move in the wind tunnel, therefore it can't change positions if they're changing suits or helmets. You can make so many incremental changes to find the smallest amounts of drag savings to piece together to get the better outcome.
So the jigsaw, all the little pieces that come together to make hopefully the big difference at the end.
Yes.
So basically a mannequin is easier to work with than an athlete, is that what you're trying to say?
Potentially, yeah.
Quite possibly.